Hello everyone, December 19th. Alright, let's do this. Image smoother. Image smoother. An image smoother is a filter. Oh, that's convolution. Alright, it's convolution network. Not network, just convolution. Filter for 3x3 that can be applied to each cell of an image by rounding down the average of the cell and the 8 surrounding cells, the average of the 9 cells. If one or more of the surrounding cells are not present, we do not consider it in the average of the 4 cells. Okay. Given m by n integer matrix image representing a grayscale of an image, return the image after applying the smoother on each cell of it. Wait, it's a 3x3, right? Wait, what's the rule? So you start from top left. For the points 0, 0, 0, 2, 2, 0. For the points 0, 0, 0, 2 is this one. 2, 2, 0, 2, 2. For the points 0, 1, 1, 0, 1, 2, and 2, 1. Oh, for points, wait, hold a second. How are you going through this thing? So you round this down, and what does that represent? 3 divided by 4. It's saying this. Oh, this is the center, right? This is the center, so it's 3 out of 4. This is center is 5 out of 6. 3 out of 4. 5 out of 6. How about the one in the middle? Oh, 8 out of 9. Ah, okay. So this will be 100, 200, 250. The one in the middle will be everybody. Gotcha. So, well, we can do it easier, because for each one you can this, right? And then for this one, down right. This one, oh, that's not down right. That should be this one. Ooh. So in here, so on the rightmost is this, right, minus this. So here, what about this one? It's the left. Oof. Hold on, so this one if I compute it on the top left corner, it's always going to be this, right? So we move here, we just add these two, right? And we move, we just remove. Maybe it's like a sliding window, right? So we go until we can now go to the right, so we always remove the two on the left. So we're done. Next, move on to this one. We will compute the whole thing. And we remove this. I don't know. Yeah, the other way will be difficult because if you have a giant, more consideration. So I might as well just add right minus left, add right minus left, add right minus left until you cannot add. Oh, it's not trivial. I think it will take some work to get this to work. Well, I need to create 0 dot length. Okay, and int its result. Right. Okay, so when we start, so we have left and we have right. So we just add right minus left, add right minus left, add right, and then minus left. Okay, so go one by one. And then we'll add. Every time we'll always add. Right? Every time we'll always add, and then we will remove. Current, in the current. So current shall equal to what I is pointing at. So it always will be something plus image I 0, okay, plus something. So what's this something? Well, this something is I is equal to 0. If I is 0, that will be 0. Otherwise, it will be image I minus 1, 0. Here is the same thing. So I is equal to n minus 1. Right? If I minus 1 is the last row, then it doesn't have anything below it. Otherwise, we'll do image I plus 1, 0. Okay, that's the current, right? And then for int j is 0, j smaller than n, j plus plus, right? Well, current need to plus equal to something. Okay, plus equal to, so we need a plus equal to the thing on the right, and that depends on the j. Holy shit. So j is equal to n minus 1, right? Then that will be 0. j equals n minus 1, which is the rightmost, then we don't have anything to the right. But otherwise we have. Then we need to do almost exactly the same as this one. So we will need to say yank this whole thing. Paste this. Oh, no. Paste it. Then we have to do something about it. So this is not I equal, yeah, it is still I equal to 0, but this is not. It should be j, right? And this is also going to be j. That's not right. So we do this, we do the next one, right? We do the next one. So it has to be j plus 1. J plus 1. So this is to add, okay? And then, so every time we move to the current j, we add on the right hand side, and then we need to minus on the left hand side, right? On the left hand side. So is j equal to 0? If j equals 0, it will be 0. Otherwise, ooh. Same thing, but this time it's gonna be minus. Right? If I is equal to, if I is equal to, no, if j is equal to 0 is the first column, then we don't have anything to the left. Otherwise we have things to the left. So yeah, so we do that. Current plus equal to, current minus equal to. So now this current is the actual current, right? And then we need to do this divided by something. And then it says we take the integer value. Right, we take the integer value. So res I j shall equal to current divided by something. Now that something is depends, right? If I is equal to 0, yeah, you might as well do this. So int count equal to, is I equal to 0? Right. If I equal to 0 the first row, and j is equal to 0, or j is equal to n minus 1, in that case we have 1, 2, 3, 4. There's only 4. Otherwise, we're in the middle. That's 1, 2, 3, 4, 5, 6. So I have 6. Right? If I is not, is I equal to 0 or I is equal to n minus 1. Right? Either the first row or the last row is going to be this. Otherwise, in the middle, it would be 9. And then this shall just be count. Right, and then we go to the next one. The current doesn't change, and then we just add minus, add minus, add minus. Once we're done, I move to the new one, we get a new current, and then we go da 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 da, then we return rest at the end. Okay, let's take a look. Ugh. So in here you add this, and you say minus this. And then when you're here, you add this. You did not add this. Oh, you should not minus this, right? Because this, and then we move on here. I add this, but I should have minus minus 1. It should be minus 2. Right, so this something is wrong here in the minus section. So if j is equal to 0, it's 0. Well, actually, it's not just 0. J is smaller than 1, smaller or equal to 1. Right? Because this, oh yeah, minus has to be j minus 2. Right? J has to minus 2. Your minus has to minus 2. And at the end, you move here, you add 0, and then you minus 2. Okay, let's try this. Is this right? First one is right, second one is wrong. The middle one is not right. Well, I will recalculate the mid. 94 should be 141. Interesting. Why is this one wrong? The count is wrong. The count is wrong. So I equals 0, I equals this. Done. Right? And There's more. Right, so it's not the first row, it's not the last row. It's gonna be in the middle, but then j is equal to 0, or j equal to n minus 1. If that's the case, will be 6, right? Otherwise it'll be 9. Let's see if we consider every situation. Oh my goodness. Oh Lord. Holy crap. How can I universally compute the count? Do I have things on the right? If I do, I add 1. Do I have above me? I add 1. Do I have left? Do I have down? Okay, so 1, 2, 3, 4. Yeah, if I have a right, if I have down, and that means we have a right down, so I add another 1. And we have up. Okay, how can I do it fast? Good. Almost. It's an easy question, but there's a lot of things to consider.
Easy level? Easy difficulty?
Yeah, it's an easy one. It's convolution network. Convolution neural network, just hand compute convolution neural network. And there's have some things. It's not trivial. There's a lot of things to consider, a lot of edge cases. I'm gonna try to find a universal solution for this. Oh.
You're warm here.
I feel alright. Oh, wait. Sorry. That one's full.
Okay.
Oh, this might work.
You lower the brightness.
Yeah, this is the lowest brightness. I'm almost done. I think I'll be done before you even fall asleep.